Hello all, let's talk about section 5.3. This section is a topic will be totally new. I'm not saying it's a review. This topic was not in intermediate algebra. This topic is new and the name of this topic is partial fractions. Focus on my lecture. This lecture will be the longest lecture in your book, and I will divide my lecture in 4 different videos. Correct? Let's start with partial fractions, but let's learn the idea what is a partial fraction or what is the partial fraction decomposition. Correct? I will write this way for you. Let's first learn the idea behind partial fractions decomposition. We call it decomposition. Please focus. I want to explain to you first what is the idea behind partial fraction decomposition. Then we start partial fractions and decompositions. Correct? From beginner algebra, intermediate algebra, we learn how to add or subtract few fractions with different denominators. For example, I'll use these two fractions, 3 over x minus 4 minus 2 over x plus 2. Correct? You can subtract these two fractions. You learned it in intermediate algebra, and it's easy to add them also. We covered this topic also in college algebra, correct? To add these two fractions, they have different denominators. You have to first find the LCM or LCD, the least common denominator or the least common multiple between denominators, correct? The LCM between these two denominators is the product of these two linear factors, correct? Which is x minus 4 times x plus 2, correct? To add these two fractions, how you deal? You multiply each fraction with the common denominator, correct? You go this way, 3 over x minus 4, and you multiply this fraction with x plus 2 over x plus 2, correct? Minus 2 over x plus 2 times x minus 4 over x minus 4, because you want to see the denominators should become the same, right? Let me keep the left side, 3 over x minus 4 minus 2 over x plus 2 equals here x minus 4 x plus 2, and distribute the numerator, which gives you 3x plus 6 minus denominators becomes the same, x minus 4 x plus 2 and distribute the numerator, which gives you 2x minus 2x plus 8. Correct? Or let me, because I write it in separate fraction, let me keep still the negative sign here, minus 8. Now to add these two, because now denominators are the same, you take one of the denominators, x minus 4, x plus 2, because they are the same, and you add the top, which is 3x plus 6 minus 2x, and you distribute the negative, right? Plus 8. On this side, still you had 3x over 3 over x minus 4 minus 2 over x plus 2, correct? Now to simplify, correct? I'll still keep the left side because I want to explain something for you. 3 over x minus 4 minus 2 over x plus 2 will give you on this side x minus 4 times x plus 2, the denominator, and at the numerator, simplify the numerator, which gives you x plus 14. Right? We did this before, adding or subtracting fractions. Now, what is the idea behind partial fractions decomposition? Actually, the opposite procedure. The opposite procedure, we call it decomposition. They give you a fraction like this, x plus 14 over x minus 4 times x plus 2. They ask you to find which fractions actually subtracted to give you this fraction or this rational expression. We call this process decomposition. Of course, in this example, I know it's 3 over x minus 4 here, and here you have 2 over x plus 2. We call these two partial fractions. This is a partial fraction, and this is also a partial fraction of which rational function? X plus 14 over x minus 4 times x plus 2. This is the idea behind decomposition of partial fraction, or the partial fraction decomposition. Now, you see, a rational expression is always in the form of p of x over q of x. P of x is a polynomial, q of x is another polynomial, but your q of x should not be 0 or cannot be 0. Any rational fraction that you see there in the form of p of x over what? Q of x. A polynomial over a polynomial. Even sometimes a constant over a polynomial. But most of them is a polynomial over a polynomial. Correct? We call those type of expressions rational expressions that I already explained to you in chapter, I think, 3 or 2. Correct? Now, few things before I start the actual lecture for you. Few notes. Let me explain few notes, which is actually they are the theories or rules of algebra. Correct? Rule number 1. There are some rules in algebra. Every polynomial can be factored into product of linear and slash r irreducible factors. Irreducible factors. What does it mean? Any polynomial can be factored in linear. Linear means you can factor it as ax plus b, correct? Ax plus b is a linear factor. And or irreducible factors, ax squared plus bx plus c, which is not linear. And some of the quadratics, you cannot factor it anymore. You cannot reduce it anymore. This is one of the theories of rules of polynomial expressions, or polynomial in general. I can say polynomials. They can be factored as a linear factor or irreducible factors. Let me show you an example. For example, if I have a polynomial in the form of x squared plus 7x plus 10, I can factor it to two linear factors, which one of them is x plus 5 and one of them is x plus 2. We already know. You see, that's the meaning of this rule. But we are talking about polynomials. Correct? Number 2. If you have a rational expression, correct? Let me write like this. Every rational in the form of p of x over q of x, when your q of x, of course, your q of x cannot be 0, correct? When the degree of p of x, let me write it here, when the degree of p of x is less than the degree of q of x, can be decomposed, into partial fractions. Let's say it this way, into partial fractions. When the degree of numerator is less than the degree of the denominator, you can decompose that rational expression to partial fractions. For example, x plus 14 over x minus 4 times x plus 2. You see, if I multiply the denominator, it gives me a quadratic. What will be the quadratic? Let's simplify it. X squared plus 2x minus 4x minus 8, which gives you x squared minus 2x minus 8, right? Or I can write this one as a x plus 14 over x squared minus 2x minus 8. If the degree of numerator, you see the degree of numerator is 1. The degree of denominator, which is q of x, is 2. The degree of numerator, or p of x, is less than the degree of q of x. Then you can write this one as a partial fractions, which I show you here. At the beginning, we start with this example. You see, definitely you can write that rational expression as a partial fractions. Correct? Now, all these notes were important. That's why you see I'm going slow. Even I'm trying to write everything for you. Now, let's start how to decompose those rational expressions. There are 4 cases. I will start with case number 1 in this lecture. Correct? Case number 1. Partial fraction decomposition of p of x over q of x when q of x has distinct linear factors. In case 1, we are decomposing the rational expressions that their denominator has a distinct. Distinct means unique. Unique linear factors. For example, what does it mean distinct? When your denominator is like this. For example, here you have x plus 2 times x minus 3 times x plus 1. You see, your denominator is distinct linear factors. It means all of them is different. They are not the same. If I have something like this, x plus 2 times x minus 3 times x plus 2, I cannot call this one distinct because I have x plus 2 and x plus 2, 2 of them. We call this one repeated. Correct? In case 1, we are dealing with this one, that your denominator, which is q of x, correct? That polynomial has distinct linear factors. Correct? Before going fast, I'll do one example, and in this example, I'm also writing all the steps for you, how to do a problem, how to do a decomposition, step by step. It's given in page 172. I'm not making something. I'm not saying that I did this for you. It's in page 572 of your book in a kind of yellowish box. They shows the steps for you. But here what I do, I'll show each step in the example for you. Correct? Then let's go this way. Let's write here steps and partial fraction decomposition. And partial fraction decomposition. Please focus each step. Step number 1. Set up the partial fraction fraction decomposition with the unknown constants for example A, B, C, etc. How many you need in the numerator, in the numerators. Of the decomposition. For example, I'll start with the example here, correct? Let's see the same example that we did. X plus 14 over x minus 4 times x plus 2. Now, the first question, which is not even explained in this step 1, how many fractions I need on the right side? To know how many of them, I need 3 of them here, like this. Up, why I went up? I need 3 fractions, I need 2 fractions, I need 4 fractions on the right side. How many I need, how I should know? Look how many factors you have. How many factors I have here? 2 factors. Then I need 2 fractions on the right side. Set up the numerator with unknown variable a, b, c. I will write this one, a over x minus 4 plus b over x plus 2. That's your step 1. Set up the partial fractions decomposition with unknown constants a, b, c, d, how many of them you need in the numerator. That's your step 1. Correct? Hopefully everyone understand. They give you only the right side. They give you only this. They are asking you to decompose. Your step 1, you need to factor the denominator, then set the right side, how many partial fractions you need, and put unknowns of a, b, c. Usually we use a, b, c in that on the right side. Correct? Step 2. Multiply both sides of the resulting equation the resulting equation by the LCD. Let me show you. Again, I'll go back to red. I have x plus 14 over x minus 4 times x plus 2 equals a over x minus 4 plus b over x plus 2. Multiply both sides of this equation by LCD. Your LCD is this denominator. This is your LCD. This is your LCD. That means I will multiply this side by x minus 4 times x plus 2. And also here I will multiply x minus 4, x minus 2 to both of these fractions, correct? Let's do it. Okay, let me write step 3. This is your step 2. You multiply both sides of the resulting equation by your LCD. Step 3. Simplify in your book. It says simplify the right side, but actually you are simplifying both sides. That's why I will write simplify the equation. I will talk general. I will show it here for you. You have x minus 4 times x plus 2 times x plus 14 over x minus 4 times x plus 2 equals, on the other side I have to multiply the same thing, which is x minus 4 times x plus 2 times a over x minus 4 plus x minus 4 times x plus 2 times b over x plus 2. Simplify. You see both of denominators on the right side cancels out. It means you will end up with x plus 14 on the left side. On the right side, x minus 4 cancels out with x minus 4. You end up with a times x plus 2. Plus, here x plus 2 cancels out with x plus 2. You end up with b times x minus 4. Still, you can simplify. Here, simplify means distribute a to this parenthesis and distribute b to this parenthesis. Then x plus 14 equals ax plus 2a plus bx minus 4b. Be careful with the signs, please. That is your step number 3. Step number 4. This example looks broken because I want to explain everything to you. Next example, I'll just solve and I explain, right? But here you see each step. I'll show it for you what to do and each step. After this example, hopefully no one will ask me again, oh, how to do it. Correct? Number 4. Write both sides in descending powers. And descending powers of x equate coefficients of like powers of x and equate constant terms. Okay, I'll copy that equation. We are here. X plus 14 equals ax plus 2a plus bx minus 4b. First, write the right side in descending order. It means you will end up with x plus 14 equals ax plus bx comes here because you want to write in descending order plus 2a minus 4b. That is the descending order. One thing that I want to explain here. Look at your first and second term. Can you factor x? Let's do it. X plus 14 equals, if I factor x, I'll end up with a plus b times x, right? This is how you factor. Plus 2a minus 4b. Equate the terms that has the coefficient, the terms that has x in it, equate the coefficients and equate the constant. What does it mean? Focus. This term, which is a plus b times x, is actually this term. Equate the coefficients. The coefficients on the right side is a plus b. That's your coefficient of x, right? How much is the coefficient of x on the left side? You see you have here 1x, 1. Also equate the constant. 2a minus 4b is a constant because there is no x involved in those terms. Equate this one with the constant on the left side. That's the meaning of step number 4. It means write 2a minus 4b equals 14. Wow, do you see you end up with the system of linear equation in 2 variables? Do you see this? How interesting this topic is, right? Step 5. Solve the resulting linear system. Solve the resulting linear system, whatever system is. Sometimes you end up with 2 variables, sometimes you end up with 3 variables, or maybe more. Hopefully in your level up to 3 system of linear equation and 3 variables. Correct? Solve it. That's your step 5. What we have? What's our system? A plus b equal 1 and 2a minus 4b equals 14. To solve this system, I have to multiply equation number 1 by negative 2 to cancel A, or B with 4, right? Whatever you like. Negative 2 is easy. Then negative 2A plus, minus, sorry, not plus. Negative 2 times B gives you negative 2B equals negative 2. If you name it, this is equation number 1. This is equation number 2. This one will be equation number 1. And 2A minus 4B equals 14, equation number 2. Eliminate. You already learned in section 5.1 and 5.2 how to deal with system of linear equations, correct? Then negative 6B equals 12. Divide both sides by negative 6. B is equal negative 2. Okay, now finding the value of A is easy. Copy equation 1. A plus B equal 1. Plug in the value of B here. A minus 2 equals 1. Add 2 to both sides. Then A equals 3. That's your step number 5. Correct? Now, step 6. In step 6, substitute something is wrong today with me. Substitute the values of A and B CD, how much of them you have, right? Let me write this way, A, comma, B, comma, C. Maybe you have more, right? A, comma, B, comma, C, comma, dot, 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 whatever, how many you have. And equation and step 1. Your equation in step 1 was x plus 14 over x minus 4 times x plus 2 equals A over x minus 4 plus B over x plus 2. That was your equation in step 1. Substitute the value of A and B in this equation. It means write x plus 14 equals x minus 4 times x plus 2 equals, how much is A? 3 over x minus 4 plus, how much is B? We found that it was negative 2 over x plus 2. If you want to write in a nice way, still this is the answer, but if you want to write in a nice way, you can write this way. X plus 14 over x minus 4 times x plus 2 equals 3 over x minus 4 minus 2 over x plus 2. You see, you decompose that fraction to partial fractions, correct? This is the process of decomposition. Hopefully, in this example, which I did step by step, you could see how you are dealing with the rational expression to decompose as a partial fractions, correct? One more example. I'll do one more for you. But in this example, I'll just solve it. I will not write the steps because in this example, it's written for you step by step. Review this lecture. When you do examples at home, when you do your homework, watch this video. Go step by step. I'm sure it's easy. You may ask me why we are doing this, why we are learning this. What is the purpose? Why I want to decompose a nice fraction? Yes, it looks really nice to you here when you have like this, x plus 14 over x minus 4 times x plus 2. It's looking nice like this here. But when you go to calculus 2, if I put this sign in front of it, find the integral of x plus 14 over x minus 4 times x plus 2. This is one of the worst integrals that we are teaching the students in calculus 2. You cannot find easily that integral as long as you change this rational expression to its partial fractions. We use this topic even in calculus 2. Believe me, I am teaching calculus 2. When I go to this topic in calculus 2 and I start talking about this, students, some of them that they didn't focus, or maybe during the algebra classes, somehow some professors are escaping this topic. They face problem there, say, oh wow, now what to do? I shouldn't explain this, you don't need this, but I'm just explaining to you that we are using this, correct, in future, in upper classes. Anyway, let's do another example. Example number 2. Decompose. What is the fraction? 5x plus 7 over x minus 1 times x plus 3. I took this example, this is actually one of the problems of the homework. I copied from your book, but let me explain something for you. Sometimes they give the denominator not as a factors. For example, if I multiply these two, you see x minus 1 times x plus 3 gives you x squared plus 3x minus x minus 3. If I simplify, it gives me x squared plus 2x minus 3. Sometimes they may give you this example like this. 5x plus 7 over x squared plus 2x minus 3, and they ask you to decompose. Correct? Don't start immediately the right side. Don't put A and B. First, factor the denominator. Factor completely. Please, factor completely. I didn't put this as a step for you. Actually, I should put this one as a step 1. But because in your book, they don't have this step. They don't explain it this way. I just follow your book. If your denominator is not given in factor form, please factor the q of x. Please factor the denominator first, correct? Which you end up, if I factor the denominator here, you end up to this, which is given to you, correct? But I'm just explaining. Every time they are not giving you that simple. Okay. 5x plus 7 over x minus 1 times x plus 3. What should I do in step 1? Write my partial fractions using a and b and c in the denominator. How many of them I need? How many partial fractions? I have two factors, then two fractions on the right side. A over x minus 1 and this one b over x plus what? 3. I always put plus sign in between. You may say, why not here negative? It doesn't matter. If you put there negative, we usually use plus, but at the end you saw in the first example, if your b is negative, then that changes immediately that sign to negative, correct? But when you do the job, put plus sign always, correct? Step 2, I will multiply both sides of this equation by this denominator, which is my LCD, correct? 5x plus 7 over x minus 1 times x plus 3. I will multiply this by x minus 1 times x plus 3 equals, I will multiply my first fraction with LCM, which is my LCM as x minus 1, x plus 3. I will multiply my first fraction with, which is a over x minus 1. And at the same time, I will multiply my second fraction with this, right? X minus 1, x plus 3 times b over x plus 3. Step 3, simplify. These two cancels out. 5x plus 7 equals here x minus 1 cancels out with x minus 1. What left? A times x plus 3. Plus here x plus 3 cancels out with x plus 3. What left? B times x minus 1. Distribute a and b to the parentheses like this. Then 5x plus 7 equals ax plus 3a plus bx minus b. Write in descending order. 5x plus 7 equals ax plus bx plus 3a minus b. Factor x here, then 5x plus 7 equals a plus b times x when you factor x, right? Plus 3a minus b. Now equate the coefficient of x with x on the left side and the constant with the constant. It means a plus b equates with 5, correct? A plus b equals 5. And 3a minus b equates to constant on this side, which is 7. 3a minus b equal 7. Correct? Solve the system. Multiply the first equation. Oh, even you don't need, this is the simple equation. You don't need to multiply. Solve the system. You see b cancels out immediately with b. A plus 3a gives you 4a equals 5 plus 7, 12. Divide both sides by 4. A equals 3. Find the value of b. Copy one of the equations. A plus b equal 5. Plug in the value of a here. 3 plus b equals 5. It means subtract 3 from both sides. B equals 2. Last step, plug in the value of a and b in the equation in step 1. This is your equation in step 1. Plug in the value of a and b here. Correct? 5x plus 7 over x minus 1 times x plus 3, you have like this, a over x minus 1 plus b over x plus 3. Plug in the value of a and b here. That means you can write 5x plus 7 over x minus 1 times x plus 3 equals a, which is 3 over x minus 1 plus b, which is 2 over x plus 3. That's the answer. You decompose this fraction as a partial fractions on the right side. Correct? I'll stop the lecture here and see you all in part 2 of this lecture. We will discuss in part 2 case number 2, how to deal with case number 2.